Good morning to you. Can you hear me, Odito Maleng? Good. I hope all is well with you and we can get started right away. The rest of the learners will obviously find us on the way. Unless they will be coming, I will be letting them in, but it cannot, delay our program that much. We just have to get going. How was the holiday? I mean, how have you been faring on? Well, I hope all is fine. I mean, in case you find any difficulty like hearing or like getting to see what I will be sharing on the screen, you just let me know. Otherwise, I think we can get started right away. You can have the option of writing a message just directly in case there is something which you would like to pass on to me, but I think we are good to go. And you see, we also have to do this fast enough so that we can get time and move on to a little bit new thing. Now, our initial project was to have this holiday. If it was not because of Corona, we would have, corrected the past exams that you guys did. But now because of this level 4 thing, we could not do that. But at least now we have the option of discussing it right here. I'm recording this discussion so that in case there are those who will not have time to join us for this lesson, they can join later and possibly maybe watch what we will have discussed. I will also be posting in the group, in the WhatsApp group, what we will have discussed, pictures and wording documents. I will be putting that right there. Now, we are supposed to be correcting all these questions here that we did, and I've broken it down. We will be doing it, me and my colleague, Mr. Alex will be doing some part. We divided it into two. I will be starting with the last bit, and he will be starting with the first bit. Let me just share with you right away the question that we are going to be correcting on the screen. Just right here. Just a minute as I share this. Right, so are you able to see what I have shared with you on the screen? Can you now see it? In case you cannot see it, you just write for me and I check. But here it's showing me that you are now able to see what I've shared with you. Now, this is physical science, chemistry paper 2 for MOTES, that is term 2 for June 2021. The total mark being 100. Examiner Alex, and the time is 2 hours, and was moderated by Mr. Edward. So I don't think we need to go through these first things. Now, the paper has got question 1, which is multiple choice. Then after question 1, we have question 2, One starts with 1.1 to 1.2 to 1.3 like that, all the way up to what? All the way up to 1.9, rather 1.10. Then question 2. Yeah, question 2 is structured, and that one you have to answer that on a separate answer sheet. Now, this is how we divided it. Question 2 up to question 3, then to question 4. Now that will be discussed for you by Mr. Alex. Then question 5, then question 6, then question 7 that I will be discussing for you. Then we will be posting the recordings of our discussion for you, also for what? For further viewing. Now, let's get started right away. Let's get started. As I told you, I will be starting it the reverse way, right from question 7 to question 5, 6 to question 4.
Which we do appreciate, but if this is ending up now, having businesses using their own security, the problem with that is that they're using
please stay mute. Can you guys please mute yourself?
And the worst thing here now is that this might be a racial thing, because we
all right, so I just request you to stay mute if you don't have a question, because if you are unmute, you know, it's going to affect our discussion. You will be having a background sound, a child playing close to you and stuff like that. And that is going to do what? That's going to cause, you know, interference. So what we are going to do now right away is to get started. I told you question 7, then question 6, then question 5. That way, then Alex will be doing 2, 3, and 4. We'll be doing it together. Then all the recordings will be posted for you guys, and you can also check on later in case you have issues with internet. So right away, question 7 that we are supposed to start on a new page is requiring us to define an acid according to Bronsted and Lowry theory. Now, we have known a lot about acids, and from the books that we have read, possibly you heard of someone discussing some things about acid, but also these things of acid, we meet it in our daily life, you see. Acid is something that we basically interact with almost every day. Now, a typical example is right here, which I hope you can see right on the screen. I shared with you just a few items that critically contain acids, you see. So for example, in vinegar, you have an acid. Also, when you are taking fruits, you know, like lemon in example, you have this citric acid. Then in wine, you also have some acid. So acid is not something which we exclusively, it's not only discussed in class. It is also something that we basically interact with every day, okay? We have this discussion of acids because it is something that we interact with almost every day. We eat it, you know, in things like fruits. We drink it in liquids, you know, like wine and stuff like that. But also in class, we restrict ourselves to our discussion of acids, not only to what we, you know, kind of like interact with every day, but also to the standard definitions. Now, our understandings and definitions of acids in classroom environment is based on the research work done by some scholars. One of them is this one, or we are now calling Lowry, who worked together with the Bronsted, and they came up with a definition of an acid, and that is the definition which is being asked for in this case. So the first question here is define an acid according to Bronsted and Lowry theory. So an acid initially was discovered to dissolve in water, and each time it dissolves, it does what? It releases or it donates hydrogen ion or hydronium ion. Now, that definition was later modified Okay, and according to Bronsted and Lowry, their precise definition of an acid is that an acid is a proton donor. Now, acid does not come by itself. Always the discussion of acid comes alongside with a base. When an acid has donated, for example, a proton, which is hydrogen ion, that proton does not just stay in air. It normally interacts again and gets combined with some other compound. Now, normally what accepts this hydrogen ion is the base. Though it's not required for us here to illustrate it, but it's important for you to know that each time the hydrogen ion is donated, it is taken up by what? By a base. So that way, we get the definition of an acid as what? An acid being a proton donor. Okay, a donor is something which gives, or someone which gives out something. So if an acid can donate a proton, then we can say an acid is a proton donor. Okay, so that is the precise definition of what? Of an acid. Now, the next thing is, well, to calculate, that is 7.2, to calculate the pH of sodium hydroxide solution of this concentration. Now, notice that this question, which is question 2, which is asking us to calculate the pH of sodium hydroxide solution, it turns out that sodium hydroxide is not an acid, okay? Basically meaning there is no way sodium hydroxide can donate hydrogen ion. Instead, sodium hydroxide is a base. What that means is sodium hydroxide accepts hydrogen ion, okay? And now in our understanding of pH, pH is very much like a measure of how acidic or basic a substance is. So for example, we could say this soil sample is acidic, meaning it has got some value, okay? It has got some measure of acidity in it or some measure of basicity in it. Or we could say this liquid is basic. It means it has got some measure of a value attached to it, which we call the pH. Now, pH ranges from 0 to 14, with the 0 to 6 being the pH for acids, and 7 being neutral, then 8 to 14 being what? Being the value for base. So now if a question is asking us to calculate the pH of sodium hydroxide solution, and sodium hydroxide being a base, how are we going to do that? Well, there is a formula we can use. Let me just get to share a new screen. That is where we are going to have our calculation, because we can't write anything much here. This calculation of pH has got formulas here and there, and division, multiplication that we have to do. So let me just share a new screen right away. Or in case I share a new screen, is there anyone with a question? Anyone who has got a question anywhere? Well, if there is no question, then I think I'm going to be moving on to sharing a new screen. Okay, let me see this new screen where we are going to do our calculation. Oh. All right, that's going to take us a little bit long. Let's try to see if we can incorporate the thing I wanted to share in this. Just have some. Yeah, so this is what we are going to use. What I thought of sharing is going to take us a little long to have. So let's use this. So pH can be calculated using a formula. And the formula is pH equals to the minus of log. Now that I need to insert, so just come over here and get this inserted. All right, log. Yes, log of hydrogen ion like this. Okay, so just have this. Okay. Yeah. So this is the formula that we use when we are doing what? We are calculating pH. So we say pH is the minus of log of the concentration of what? Of hydrogen ion. Now, this is how we calculate pH. Well, now the question we are dealing with is, what type of information do we have? Well, let's check on the question again and see what we can get from there. Yeah, the question that we have has given us the concentration of sodium hydroxide, okay? The concentration of sodium hydroxide is what we have been given. And now we are looking for pH, and sodium hydroxide is not an acid, it's a base. So how do we deal with that? Well, let's just write that information first down. So we say concentration of sodium hydroxide, or very much, we can then put this, the concentration of hydroxide ion, like this, is what has been given as what? 0.75. Yes, that is what we are dealing with. So how are we going to manage this? Well, there is one other formula we can also use to get these things done all in order. And what's that formula? The formula that we are going to deal with here is that the P of H, pH plus P of hydroxide ion, okay? They all add up to give what? They all add up to give 14. Now, from here, we can calculate the value of pH. The only thing we just need to find out is what is going to be the value OP of the hydroxide ion. How are we going to get that? We use the similar formula, okay? The similar formula here is that P of OH, okay, of the hydroxide ion, OH, can be calculated from the minus of what? The minus of log. Let's use this. Oh, sorry for this. Okay. The minus of log of hydroxide ion. Oh, right. There we go. Only that we have a minus there. Yes. So that's the formula that we are now going to employ. Okay. That is the formula we are going to use, because what we need now is the value of POH, so that we can find the value of pH, okay? We know that when we add pH to POH, we must get what? We must get 14. We have the concentration of hydroxide ion. So when we put it right inside here, well, we can find a value. And what's that value going to be? Well, let's see. So we are going to be having minus log of hydroxide ion. In this case, it's what? The concentration is 0.75. Okay, so this way we can find the concentration. And what is the concentration going to be? Well, the concentration, let's get our calculator right away and find the value of that. So minus, if you do have a calculator with you there, this is the time to employ it into a serious work. Minus 0.75. Yeah, so this one will give us a value of 0.1249. Yes, that's what we have got so far. Okay, and now from here, we can go ahead to substitute this value we have got right in this so that we can find the value of what? The value of pH. So let's go ahead to do that. So we say pH plus the value that we have got, which is 0 what? 0, okay, we substitute this right here. And what do we get afterwards? Well, we first equate it to 14. Yes, from here we can find the value of pH. And so pH can be calculated when we do what? When we take this 0.1249 onto the right-hand side. Okay, so we go ahead and say pH is going to be equals to 14 minus that value. Okay, 14 minus this. And what is this value going to be? Well, pH is going to be calculated, and this will give us, let me see, with the calculator right here, 14 minus 0.1249. Yeah, that will give us a value of 13. Give us a value of 13. 13, what? 8751. Yes, that is how we calculate pH, okay? The information given was not direct, so we had to do what? We had to first find the concentration, the other side, and yeah, now this is just one method, okay? We could also use another method to find what we call the pH, okay? We could use one method which is called which is derived from the equilibrium constant of ionization of water. Okay, like when water reacts by itself, you know, water itself is a compound, you know, when hydrogen and oxygen mix, the two reacts, and when they react, they can ionize themselves, you know, they can break down into ions. And so the concentration, rather the constant of equilibrium, or the equilibrium constant, can also help us to find the value of pH. I am bringing in this idea because, you know, there are some materials, there are some textbooks which will be using this. And if you understand that first, okay, if you get to understand the approach of calculating the pH from the concentration, or rather the equilibrium constant, this method here, which we have used as the first option, may be a little bit, you know, new to you. So let's also use that method, and we see what we can get out of it. So now, using this method here, the equilibrium constant K is calculated when we multiply the concentration of the hydroxide ion and the concentration of the hydrogen the hydrogen ion. So that way we will be getting the concentration of H times the concentration of OH, like that. Let me just put the subscript for the formula so that it will not be so confusing for you. So the subscript here is minus, and here is plus. So let me have it indicated right there. Plus, yes. So from here, we can calculate the value of pH, okay? Because the constant of ionization is 10 to exponent what? Minus 14. So that will give us a value of 10 with minus 14 over there, like that. So that is the formula that we can also use, okay? Because the original formula to calculate, pH will still be the same. This one here, pH equals to minus of log of what? Of the concentration of hydrogen ion, and P or H equals to minus of the log of the concentration of hydroxide ion. Now, since we have been given the concentration of hydroxide ion, we can use this formula here, which is the concentration of hydroxide ion times the concentration of hydrogen ion gives this value here, which is 10 raised to minus 14. Sometimes you find written 1 times, okay? But it's just the same. It's the same thing. Sometimes you find written as 1 times the concentration. So if you find it written as 1 times, it's still the same thing. You can still reduce it to 10 what? With that. So now this way, if we substitute the concentration of hydroxide ion, now notice that the concentration of hydroxide ion is what has been given as what? 0.75. This is what we have been given. And so if we substitute this one right there, what are we going to get? Well, let's check and see what we are going to get. So here we'll be having, well, our original formula, the formula now we are going to use is this part here. We will leave the other K. So the formula we are going to use, or we would like to use, is this formula. Now with this formula here, we know the concentration of what? Of hydroxide ion. And it's what? It's 0.75. So we will be like, to calculate the concentration of hydrogen ion, to calculate this, we just, well, let's just substitute here. Then we say times the concentration of hydroxide ion, which in this case is what? 0.75, okay? So we'll be having 0.75 equals to what? 10, okay, with exponent minus 14. So that is what we have. Now we use this formula so that we can find the concentration of what? The concentration of hydroxide, rather hydrogen ion. And so from here, we can go ahead, okay? To find the value of the concentration of hydrogen ion, we now have to take this the other side. We just divide because, you know, there is multiplication here. So we just conclude and say the concentration of hydrogen ion, okay, which is this one here, is going to be 10 with exponent minus 4 divided by what? Divided by, first put it here, we divide this by 0.75. So let's do this and see what we are going to get. Just remove this first and yeah, just want to do something here, and this is blocking me a lot. So let me just put it down here. Yeah, it's better if I put it down there. So yeah, I just wanted to divide this. And when we do that, divide this one here, what do we get? 0.75. Yeah, we get the concentration of hydrogen ion. And what is this going to be? Well, let me divide it right away here with my calculator. This is 10 raised to minus 14. Now, when we divide this by 0.75, what we get is 1.33. That is 1.33 with exponent what? No, This is not have been given. I've been given 133 point, rather comma 33 with the exponent of, that is times 10. This 10 is again raised to minus 16. Like that. So yes, that is the concentration of what? That's the concentration of hydroxide, rather hydrogen ion. The next question we want to deal with now is, how are we going to compute the pH? So to compute the pH, what we do is we use the formula. And what's the formula? The formula here is pH equals to minus log of what? Log of the concentration of the hydroxide ion. So rather of a hydrogen ion. So that's what we put right here. Now we know the concentration of what? Of hydrogen ion. So we just substitute it here. So let's see, let's have this one substituted right inside there, and we see what we get. Like this. So let's see what we get from this. What we're going to get from this is going to be the value of pH. So if you do have a calculator with you right there, it's okay. You can go ahead and check that value. So this is going to be the minus of the log of what? 133, 33 times 10. Oh, this is supposed to be minus 16. I forgot to put the minus. Sorry for that. There is supposed to be minus here, and it is also supposed to be minus here. Yeah. So this is going to be 10. Then minus 16. Yeah. So when we do this, the value I'm finding here is 13,875. Yeah, 50 or 51, like that. So we check to see with what we have, what we got previously here. You see, it's basically the same value. So this is what we got previously. pH being what? 13.8751, and that is also what we have got right here. So now it's basically, you are the one to decide which formula is it's easy for you to remember. Are you going to use the formula of pH plus POH equals to 14? Or you're going to use the formula of the concentration of hydrogen ion times the concentration of hydroxide ion equals to 10 with exponent minus 14. So that is now your choice, but what I have to say is all the formula will give you what? The same value. Okay? So any question up to that? Now, in case you do have a question, just feel free to text it, okay? You can just write it down. You don't need to say much. You can just write that there is this part here which I have not understood, okay? Then I will come and explain it. Otherwise, this is how you would do question what? This is how you would do 7.2. Now, the next thing is 7.3. And let's see how we are going to handle 7.3. And what's the question for 7.3? Well, the question for 7.3 right here, I hope you can see that. 7.3 is basically the last bit of the question. That's the last bit of question 7. They're talking about seashells, and it's that seashells contain calcium carbonate. Now, in a test to find the percentage of calcium carbonate present in seashells, 75 cubic centimeter of a 0.5 mole per cubic decimeter of hydrochloric acid solution is added to a 5-gram sample of seashells. Now the acid, this is some additional information. The acid is in excess. Now, the balanced equation for the reaction is given below. Okay, so basically, what this question is talking about is that seashells, they contain this compound we call calcium carbonate. Okay, but now what we are required to do, or what is required to be done, is to determine, because it is not only calcium carbonate which is inside there, there are a lot of other impurities and other compounds. So the question which is now requiring us, or the question at hand, is we have to determine the percentage of calcium carbonate which is present. Okay, so very much like saying, well, this is a sample. It's like, well, this is some sauce that is ready for eating, but how is the salt? Is the salt fine? Is the salt not too much? How about spices? Is the spices too much, or is everything fine? You see, that's the type of thing we are dealing with right now. We are supposed to determine the percentage of calcium carbonate which is present. We already know, according to this statement, that calcium carbonate is right here. Okay, so how are we going to handle this? How are we going to deal with this? Well, the other information is that the acid is in excess. Now, when the acid is in excess, what that means is that the reaction will not be, it will not be a neutral reaction, okay? In other words, the acid inside there is just too much. So because the acid is just too much, we first need to neutralize it, okay? There is supposed to be a need to find out, how do we make sure that the acid inside there is not too much? It's like when you're trying to prepare a sauce, it's like when you're cooking, and for some reason you have noticed that the salt you have added is not enough. Well, in this case, if it is not enough, you just have to add some more, okay? But should it happen that the salt you have added is simply too much, then you have to find a way.
Well, Annika, I'm not going to go out because Cecilia and I are not necessarily safe over here. As you can see, as these workers load, the looters are at Senate.
Yeah, sorry for that. You guys, please, I request if you want to say something, just do it a proper way. Don't just unmute like that, because you know the background sound will be affecting what we are discussing. Okay, the sound interference. So what I have been saying is, if you are preparing something and it has happened that there is too much of one component, you have to find a way of neutralizing it. Now, in titration, normally what we deal with is the element of solutions. Normally, we want to find the concentration of one solution using what? Using a standard solution. So we basically have to mix an acid with a base, okay? And it must have a neutral reaction. Then now, one of the solution must have a non-concentration, and we use that non-concentration to help us find the what? The concentration of the other compound. If the concentration of the acid is known, then now we are going to use the concentration of that solution to find the concentration of the base. If the concentration of the base is known, then we have to use the concentration of the base to help us find the concentration of the acid, you see. So that is what we deal with in titration, okay? So now, how are we going to get this done? Now, to get this done, let's first continue reading this. They said the excess acid required 22 cubic centimeter of the above sodium hydroxide solution for complete neutralization, okay? So now, well, the good news here is this. The excess acid can now be neutralized, okay? And to neutralize that, we need 22 cubic centimeter of sodium hydroxide with the concentration, okay? Rather, the sodium hydroxide which is required here is the sodium hydroxide, which we used in this discussion here. You see, you remember we were calculating the pH of the sodium hydroxide, and we did that. So this very same sodium hydroxide is now what is being used, and they need up to what? Up to 22 cubic centimeter. That is now the volume, okay? So there is a need to add 22 cubic centimeter of sodium hydroxide solution to help with the neutralization. Now, for this part only where there is neutralization, what you notice here is that this acid, the hydrochloric acid, which now requires sodium hydroxide, will react to give these products here. So what are we going to do here? Well, the information we have right now is about the sodium hydroxide, okay? So what we are going to do is, well, this is the volume of sodium hydroxide, which we have, and this is the concentration of sodium hydroxide, which we have. Now, since we know the volume of sodium hydroxide and the concentration of sodium hydroxide, we can then go ahead to calculate the number of moles of sodium hydroxide which is used to neutralize the what? The excess hydrochloric acid. Now, after knowing the number of moles, the next thing is going to be, we have to check the mole ratio, okay? Now, notice that here, 1 mole of hydrochloric acid is reacting with the 1 mole of what? With sodium hydroxide. So the mole ratio there is 1 to 1. So there we have dealt with the what? We have dealt with the excess hydrochloric acid. Now that we have dealt with the excess hydrochloric acid, we will then come in to check with from this calculation, rather from this reaction here. Okay, we will now move into that reaction and we see the number of moles that reacted. Okay, the number of moles of what? Of hydrochloric acid that reacted. That will help us, that will inform our decision to calculate what? To calculate the percentage of calcium carbonate which is present inside. So that is going to be the process. Okay, so we will start with a reaction which is neutral, a complete reaction. So how are we going to handle that? Well, now we have the what? We have the concentration here of sodium hydroxide, 0.75. We also have the volume. So let's just put that down right away on our page for the calculation right here. So the volume is 22 cubic centimeter. Now notice that we have to convert this, okay? Notice that we have to convert this 22 cubic centimeter from cubic centimeter to cubic decimeter, because the concentration we are dealing with is in cubic what? Is in cubic decimeter. So we want to maintain consistency. We want to ensure that the calculation we are doing, they are in what? In their standard units, okay? The required units which is given in the question. So here we are going to convert from cubic centimeter to cubic decimeter. And when we do that, or while we do that, we do it by what? We do it by multiplying this quantity which we have got, 22, by what? By 10. We do that when we multiply this by 10 raised to power what? We raised to power minus 3. Like that. So now what we have got here is the volume in what? In cubic decimeter. Like that. So what else do we have? We do have the concentration. So we say the concentration of sodium hydroxide, which is our base in this case, the concentration here equals to what? It was given as 0.75. Okay, 0.75, like that. So that's the concentration. So we can now go ahead to calculate the number of moles, okay? Since we have the concentration, let's go ahead to calculate the number of moles. So how do we calculate the number of moles? Well, we calculate the number of moles when we multiply the concentration times the volume. Now notice that the original formula is concentration equals to volume divided by rather the number of moles per unit volume. So the original formula is C equals to N over B, like that. So to find N, we just multiply that. So let's do that. We now say the number of moles is going to be calculated when we multiply the concentration times the volume. And what is this going to be? The concentration is 0.75 and the volume is here. Let me just get it right away. So we substituted right here. Say times that. So what do we get from here? Well, what we are going to get from here is going to be the number of moles of sodium hydroxide that neutralized the excess hydrochloric acid. So let's get that done right away. So this is going to be 0.75 times 22 times 10 raised to power -3. Okay, raised to power -3. That will give us 0.0165. Okay. Well, now this is what we have got so far. Okay. This is what we have got now. This is the number of moles of what? This is the number of moles of sodium hydroxide that was used to neutralize the excess hydrochloric acid. Now that we have got that, we can then say now, because notice the mole ratio is 1:1, okay? You see here one silent one and there is one here. Since the mole ratio is 1:1, we can also say that the number of moles of excess hydrochloric acid is equals to the number of moles of hydrochloric acid. So that means we can then conclude, okay? We can therefore say, if this was the number of moles, if N, what we have calculated is the number of moles, just put this as NB, just write this as NB instead of just N. So I'm going to call this NB, just like that. Okay. Yeah. Yeah, so that is NB. Now we need NA. So we say NA, okay. A being the not like this. Just put this NA. That is the number of moles of what? The number of moles of excess hydrochloric acid is also 0.0165. All right, so that's what we are dealing with at this time. Here I'm seeing a question, when was the concentration given? Okay, now the concentration that we are using in this calculation, let me just show you right away here. You see, this is the concentration. The concentration was given in question 7.2. In question 7.2, we were supposed to calculate the pH of sodium hydroxide solution of a concentration given here. And now when you read this other, when you read this other statement here, that the excess acid required 22 cubic centimeter of the above sodium hydroxide solution. Of the what? Of the above sodium hydroxide solution. Where above do we have sodium hydroxide solution? Sodium hydroxide solution is only appearing in 7.2. That is what they are referring to as above, okay? So this is where the concentration is given. The concentration was already given as indicated above. And above, we have sodium hydroxide solution of concentration what? 0.75. Okay, so yes, I hope you get that. That is for your question. Now the next thing now is we have now known the number of moles of excess hydrochloric acid. The thing now we want to do is we now have to determine how about the number of moles of hydrochloric acid that participated in this reaction here. Yeah, there we go. You see? Now that is what we want to deal with. We have used the neutralized reaction to help us find the number of moles of excess hydrochloric acid. Because they say there was excess hydrochloric acid, meaning, well, some moles reacted, others did not. So the excess that reacted is what? Is what we have got. Now, we want to now determine the number of moles that what? That reacted. Now, notice that we have been given here that in a test to find the percentage of calcium carbonate present in seashell, 75 cubic centimeter of a 0.5 mole hydrochloric acid solution is added. So what do we do here? Well, just really quick, the volume here given 75 is the volume of what? Of the hydrochloric acid. Then this one here, 0.5, is the concentration of hydrochloric acid, okay? Sometimes, I know sometimes it may be a little bit difficult for you to identify. How do you know this is volume and how do you know this is concentration? You look at the unit. Cubic centimeter is a unit for volume. Mole per cubic decimeter is a unit for what? Is a unit for concentration, because concentration is what? Is number of mole per unit volume. So there we go. Now we have this 75 and we have this 0.5. So what that means is we can calculate. Okay, we can now go ahead and calculate the number of moles of the hydrochloric acid present. Then we will then calculate the number of moles of the hydrochloric acid that was used in the reaction indicated here, which I highlighted. So let's go ahead and do that. So we have 75 for what? For the volume, and we have 0.5 for. So there we go. Let's have this right away. Now we say, since volume of the acid, okay, let's just say VA, the volume of the acid is given as 75. We have to convert it, okay? We have to convert this one here from cubic centimeter to cubic what? To cubic decimeter. How do we convert that? We convert it by multiplying it. We convert by multiplying it times 10 raised to power what? Times 10 raised to power negative 3. Like that. So now that's the volume, okay? Then the next thing is the concentration, Ca. So what's the concentration in this case? The concentration is given as 0.5, like that. So the number of moles in this case, the initial number of mole of the whole thing, we are going to write it as, well, n what? Let's just call it n. And lowercase. So this is going to be equals to what? The product of the two, which is 0.5 times what? 0.5 times 75, and 75 is times 10 raised to power what? Times 10 raised to power minus 3. Like that. So let's see what we get here. So what we get here is going to be 0.5 times 75 times 10 raised to times 10 raised to negative 3. Yes, that's going to give us the number of moles which in this case is what? Which in this case is equals to 0,0375. Yeah, so this is what we have. Let me just bring it right up there. Okay, so this is what we have. Now, let me explain this a little bit. What we have just calculated is the number of moles of the hydrochloric acid, the whole thing, okay? Now, this number of moles, part of it reacted, part of it was excess, you see that? And so because part of it was excess, we now want to determine the number of moles of hydrochloric acid that reacted. So the number of moles of hydrochloric acid that reacted is going to be this value which we have got minus the excess, okay? It's going to be this value which we have got minus the excess. So the number of moles of hydrochloric acid that reacted, let me just call this N, or just to differentiate it, okay? Just to differentiate it, NO is going to represent the number of moles that we had initially, okay? The number of moles. You can use any subscript, it's fine, okay? You can use anything for as long as it's clear enough for the examiner to understand. So this is what we have. So now the number of moles that reacted, okay? The number of moles that reacted, let's call it N, okay? NR, as an example. Yeah, just that. The number of moles that reacted. Let's just call it NR. And this is going to be what? This is going to be 0,0375, okay? Minus the number of moles that was excess. And what's that? Let's see. The excess here is 0.01, like that. So we just fix it right here. Okay, so this way, what do we get? Well, this we get the number of moles that reacted, and what is it going to be? So you do have a calculator with you right there. Just go ahead and do what? Go ahead and find the value. And let's see what you have got. Now with my calculator here, I'm going to substitute it right away. It's going to be 0.03 0.0375 minus 0.0165. Yes, like that. And this will give us a value of 0.021. Yes, this is the number of moles of what? This is the number of moles of hydrochloric acid that reacted. Now, you see, the interesting thing we are dealing with here is that the question actually is asking for the number of what? Is asking for the percentage of calcium carbonate. So now we need to know the number of moles here, because we are supposed to test, or we are supposed to find the percentage of calcium carbonate present here. So now let's go ahead and find the number of moles. Now notice that the mole ratio here is 1 to 2. Very much like saying for every 2 moles of hydrochloric acid, there is 1 mole of what? Calcium carbonate. So what does that mean? To find the number of moles of calcium carbonate, what do we do then? We divide by 2. So we say the number of moles in this case is going to be, that is the number of moles of calcium carbonate. We are just going to get this done really quick. Almost running out of time. So we say the number of moles of calcium carbonate. How are we going to represent it now? Well, let's say the number of moles of calcium carbonate. In this case, let's just call it N of calcium carbonate. It's going to be equals to what? It's going to be equals to half of this, which is 0.021. This one we have to divide it by 2. Okay, we have to divide it by 2. Why do we divide it by 2? We divide it by 2 because of the mole ratio. The mole ratio is such that for every 1 mole of calcium carbonate, there is what? There is 2 mole of hydrochloric acid. Now, what we have right now is the number of moles of hydrochloric acid. That means to find the number of moles of calcium carbonate, we have to divide this value by what? By 2. So when we divide this value by 2, what do we get? Right again here, we just have to divide this now by 2. And this one will give me a value of 0.0105. That is what we have got, okay? So yes, from here, we now have the concentration of the number of moles of calcium carbonate. So after finding the number of moles of calcium carbonate, well, how about the mass we are dealing with in this case? Okay, so, well, again, using the formula N equals to M out of M, here over the molar mass. We already have N, we already have M. Can we find M, which is capital M? Yeah, we can do that. Well, why are we doing this? Why do we have now to find the mass? Okay, we are doing this because, let me just show you. Yeah, you see, we are doing it because in this question, they are talking of some addition of hydrochloric acid to a 5-gram sample. Okay, so now to find the percentage, we need to know the mass which is available right now. Then we compare it with the mass which has been given. And when we compare that way, we can get the percentage, okay? The required percentage. So that way, we first need to find the mass. So to find the mass, as I have indicated here, we use the formula number of moles equals to M out of capital M. So this is the molar mass, we know this, okay? So we say mass M, okay? Mass M is going to be equals to N, which is what? 0.0105, like that. We are going to multiply this with what? We are going to multiply this with the molar mass of calcium carbonate, okay? Like that. So now calcium carbonate has got a combination of calcium, carbon, and oxygen. Calcium 20, carbon, well, carbon gives what? Let's see this. 12 and this 16. Let's try to compute this really quick. We look at the atomic mass for calcium. Then we add to the atomic mass of carbon. Then we add to the atomic mass of oxygen. Okay, like that. So let me have it written here. Now the molar mass of calcium carbonate, okay, is going to be the combination of the atomic mass of calcium, which is 40. We are going to add this to the atomic mass of carbon, which is 12. And we will also add this to the atomic mass of oxygen, which is 16. This 16 is going to be multiplied by 3, okay? So that we get like that. You know, we are using this formula here. Yeah. So we have this 40, we have this 12, we have this 16 times 3. So that will give us a value of 100. So from here, we get a value of 100. So what's going to be the mass here? Well, the mass M is going to be equals to, what is this again? 100 times 0.0105. That will give us what? 1,05. That's the mass. Okay. So after getting the mass, the next thing that we now want to deal with is to calculate the percentage. So to calculate the percentage, just substitute right away the percentage right now, the percentage of carbon dioxide, calcium carbonate rather. So we say the percentage of calcium carbonate, percentage of calcium carbonate right here. Okay, just putting this right there. Okay, yeah, so let's make it big enough. Yeah, the percentage of calcium carbonate can then be calculated when we divide this mass by the mass which is given, and we express it as what? As a percentage. So this is going to be this mass which we have got, okay, divided by the mass which we were given. Okay, so very much like we just have to substitute the value. And what is this mass which we have got? We have got 1,05. Then what was given? 5. Okay, so using the calculator that we have, we are expressing this as a percentage. Okay, so we are going to multiply this by 100 like that. So that way we can find the value. So what's the value going to be? Let's see. This is 1,05 divided by 5. Okay, it's going to be 0.21. Then when we multiply that by 100, we get 21%. So yes, 21% is what is available there. Right, like that. So yes, this is how you would handle what? This is how you would handle question 7. So once again, if you're given a similar question like this, step 1, you have to look for the balanced equation first. In other words, if the equation is not balanced, you have to rather if the reaction is not neutralized, then you have to find a way of neutralizing it. Okay, normally it can be neutralized when the excess of one solution is first dissolved somewhere. So yes, you guys, I think we have got to stop here so that we move into the mathematics class. In case you are also a mathematics learner, then you just stay there. I will be going for a break of around 5 minutes before I get into the mathematics class. So that is how we are doing it, you guys. This is how we are doing it. Unfortunately, I first have to close this. Then I open a new class so that this one will be saved somewhere. So you guys, it was nice having you there. Let me first close this, then I start again for the mathematics class.